I'm going to teach you about Eloquent JavaScript. This can be found online, eloquentjavascript.net. Introduction. We think we are creating the system for our own purposes. We believe we are making it in our image, but the computer is not really like us. It is a projection of a very slim part of ourselves, that portion devoted to logic, order, rule, and clarity. Written by Ellen Ullman, Close to the Machine, Technophilia and its Discontents. This is a book about instructing computers. Computers are about as common as screwdrivers today, hence the picture. But they are quite a bit more complex, and making them do what we want them to do isn't always easy. If the task you have for your computer is a common, well-understood one, such as showing you your email or acting like a calculator, you can open the appropriate application and get to work. But for unique or open-ended tasks, there probably is no application. That is where programming may come in. Programming is the act of constructing a program, a set of precise instructions telling a computer what to do. Because computers are dumb, pedantic beasts, programming is fundamentally tedious and frustrating. Fortunately, if you can get over that fact, and maybe even enjoy the rigor of thinking in terms that dumb machines can deal with, programming can be rewarding. It allows you to do things in seconds, what would take forever by hand. It is a way to make your computer tool do things that it couldn't do before, and it provides a wonderful exercise in abstract thinking. Most programming is done with programming languages. A programming language is an artificially constructed language used to instruct computers. It is interesting that the most effective way we've found to communicate with a computer borrows so heavily from the way we communicate with each other. Like human languages, computer languages allow words and phrases to be combined in new ways, making it possible to express ever new concepts. At one point, language-based interfaces such as the BASIC and DOS prompts of the 1980s and 1990s were the main method of interacting with computers. They have largely been replaced with visual interfaces, which are easier to learn but offer less freedom. Computer languages are still there if you know where to look. One such language, JavaScript, is built into every modern web browser and is thus available on almost every device. This book will try to make you familiar enough with this language to do useful and amusing things with it. JavaScript is the focus of this story. JavaScript also created something called Minecraft. On programming, besides explaining JavaScript, it will introduce the basic fundamentals of programming. Programming, it turns out, is hard. Yes. The fundamental rules are simple and clear, but programs built on top of these rules tend to become complex enough to introduce their own rules and complexity. You're building your own maze in a way, and you might just get lost in it. Yep. There will be times when reading this book feels terribly frustrating. Yep. If you are new to programming, there will be a lot of new material to digest. Yep. Most of this material will then be combined in ways that require you to make additional connections. It is up to you to make the necessary effort. When you are struggling to follow the book, do not jump to any conclusions about your own capabilities. You are fine. You just need to keep at it. Take a break. Reread some material and make sure you read and understand the example programs and exercises. Learning is hard work, but everything you learn is yours and will make subsequent learning easier. This is beautiful, beautiful words. When actions grow unprofitable, gather information. When information goes unprofitable, sleep. I'm about to go to sleep. Ursula, that's an awesome name. The Left-Handed Darkness. We need to look that up. It is 12:28 here. I'm about to go to sleep. The Left-Handed Darkness. Okay, it goes from $2 on eBay to $270. Wow. Published in 1969. God, I get some sleep. Alright, how much have we done? We recorded 5 minutes, and I don't know if I can take it. That's really cool. I get distracted very easy. A program is many things. It is a piece of text typed by a programmer. It is the directing force that makes the computer do what it does. It is the data in the computer's memory. Yet it controls the actions performed on the same memory. Analogies that try to compare programs to objects we are familiar with tend to fall short. A superficially fitting one is that of a machine. Lots of separate parts tend to be involved, and to make the whole thing tick, we have to consider the ways in which these parts interconnect and contribute to the operation of the whole. A computer is a physical machine that acts as a host for these immaterial machines. Computers themselves can do only stupidly straightforward things. And I'm getting thirsty. The reason they are so useful is that they do these things at incredibly high speed. A program can ingeniously combine an enormous number of these simple actions to do very complicated things, especially if it's an impossible infinite loop and it just kills itself. A program is a building of thought. It is costless to build, it is weightless, and it grows easily under our typing hands. The program. But without care, a program's size and complexity will grow out of control, confusing even the person who created it. Oh yeah, that makes sense. Keeping programs under control is the main problem of programming. When a program works, that's the octopus. When a program works, it is beautiful. The art of programming is the skill of controlling complexity. The great program is subdued, made simply in its complexity. Some programmers believe that this complexity is best managed by using only a small set of well-understood techniques in their programs. If you really read this out, if you do some and read this out, it's really good. They have composed strict rules, best practices. That's really good. Because there's so many different ways to do it. Prescribing the form programs should have and carefully stay within their safe little zone. So I'm thinking about all this stuff. I've been programming for about a month now, maybe 4 months, just practicing, but really got into it the last month. This is not only boring, it is ineffective. New problems often require new solutions. The field of programming is young and still developing rapidly, and it is varied enough to have room for wildly different approaches. There are many terrible mistakes to make in program design, and you should go ahead and make them so that you understand them. A sense of what a good program looks like is developed in practice, not learned from a list of rules. And I am not reading this. It's a program to add the numbers from 1 to 10. I don't even know if I'm going to read all this. This is really basic. That was really good before that. Language matters. Yes. To program early computers, it was necessary to set large arrays of switches in the right position or punch holes in strips of cardboard. Oh, okay. Yeah, that's ancient. And feed them to the computer. You can probably imagine how tedious and error-prone this procedure was. Even writing simple programs required much cleverness and discipline. Complex ones were nearly inconceivable. If people study about computers, they will know basically this stuff. The beginning part was really motivational. Okay, ones and zeros. guess I could read this out. Store the value of memory location 1 and memory location 2. Subtract the number 11 from the... I don't really want to read all that out. Although that is already more readable than the soup of bits. It's rather obscure, yes. And there's a loop. Can you see how this program works at this point? The first two lines gives 2 memory locations. Okay, so we're setting it. JavaScript usually let total equals 0. The lines using compare are probably the weirdest ones. Set compare to count. Subtract 11 from compare. Our program wants to see whether count is equal to 11 to decide whether it can stop running. Because our hypothetical machine is rather primitive, it can only test whether a number is 0 and make a decision based on that. So it uses the memory location labeled compare to compute the value of count. Well, subtract minus 11. It makes a decision based on that value. The next two lines add the value of count to the result. And they increment count by 1 every time the program has decided that count is not 11 yet. And here we go. There's JavaScript. Okay, thank you. Oh, wow, we can do it here. This is cool. This is always fun. So they're telling you the answer. I don't know why they always put that in there. You can run the code and get 55. Let total equals 0. Count equals 1. While count is less than or equal to 10, total add to the count, add 1. That's this add 1. We're subtracting 11 here. And console log the total. And we get 55. And if we change this to 11, you get 66. Less than or equal to. Less than or, oh, you're doing it that many times. It's going to come up to, please be 2, please be 2. 3. Lost. This version gives us a few more improvements. Most important, there is no need to specify the way we want the program to jump back and forth anymore. The while construct takes care of that and continues executing the block wrapped in braces. Yeah, these are the braces. Oh, sorry. Here's the braces. As below, as long as the condition it was given holds. The condition less than or equal to 10, which means count is less than or equal to 10. We no longer have to create a temporary value and compare that to 0, which was just an uninteresting detail. Part of the power of programming language is that they can take care of uninteresting details for us. Oh. 1 plus 2 plus 3. What is 3 plus 3? 6. What is 6 plus 4? This is 10. What is 10 plus 5?